Okay, so let's try to solve this problem. It's a medium Leetcode problem, and it's based on dynamic programming. So let's try to solve this problem. So we have to identify the longest palindromic string. So what exactly is a palindrome? If you read it from left to right or right to left, it is one and the same. So let's consider this specific example. Uh, so if let's say we have this example wherein we have B, A, B, A, D, right? We know that BAB and ABA are palindromes. How do we know that? Read it from left to right or right to left. It is one and the same. Let's consider another example like B, A, B, A, and then again another B. So in this case, we know that this is also a palindrome. How do we know that? We consider this to be center, and then the values that are here and the values that are here are same. So this is how we can quickly verify if a specific string is palindrome or not. Read it from left to right and right to left is one and the same. Also, if you take a center and you check for the values to its left and to its right, it is one and the same. So using this simple logic, we can simply write the program. So here, if you see the valid answers here are BAB as well as ABA. But if this is the input, then BAB would be the valid answer because this is longer than ABA and BAB, which is of length 3. So the longest length here would be 5, and we have to output a value which is BAB or ABA, right? So let's consider the second example here. We have CBBD, right? So if you see here, the longest palindrome is BB, which at this specific center, BB is the center, uh, is the longest palindrome. But let's consider another example, which is like C, B, B, and then another C. So this would be the center, and this would be also equal. So here the length would be 4, and the solution would also be CBBC, right? So considering these values, let's try to solve this problem. So all we have to do is for every index like B, A, B, A, D is the question, right? At this index, let's verify if this is a palindrome with center at the specific value. And if you consider that, you have to next check the values at its left and at its right. There's nothing at its left, so the maximum length that we can get at this particular index is 1. And if you check from here, it would be 2 because at A and at BAB, we will get the values. It's not 2, it's 3 actually. This is the maximum length, which is 3. And at this value as well, we'll get 3. And at this value, we'll get uh, 1, which is only 1. I mean, which is only A because BAD is not a palindrome. And at this, again, we'll get 1. The minimum that we can get at any particular index would obviously be 1. But the same thing we have to do with we will have to consider two values as the center as well, because it might be possible that the input might be something like this. So we have to consider these both to be the center, and we'll get a length of 0, and these both to be the center, we'll get a length of 2. So when we get a length of 2, we'll have to make sure that uh, we identify the start and end values correctly. So let's evaluate the start and end values based on the index. So let's consider we have an index I, which will be 0 at B is equal to 1. And let's directly solve all the values. So we need a start value and we need an end value. And let's consider the length would be 1 at this particular value. How exactly we get to the length of 1, we can solve it in programming, but uh, so in this case, I is at length 0, right? So I That is what the start is, and end should also be I, right? So, okay, this is okay. Next, let's consider the next value, which is I is equal to 1 and length is equal to 3. So in this case, we have to get a start value that we are expecting is 0 and an end value that we are expecting here because it starts at B and ends at B here. So this is 0, this is 1, and this is 2. So we want the end value to be 2. So we want the end value to be 2. This is the expected value. Uh, Let me erase this first. Okay, this is 0 we are expecting, and this is 2 we are expecting. So the value of I is 1. The value of I is 1, and then we have start, which we can subtract uh, the length. So the length is 3 here, uh, and we can divide it by 2. So this will be 1.5, right? So this will be 1 minus 1.5, which will be 1.5 when converted to string will obviously be 1. So 1 minus 1 will be 0. That is fine here. So I and plus 3 divided by 2. So this will again be 1.5 and this will be 1. So the value here would be 1 plus 1, which is 2. Wait. The values here is 0, 1, 2. Yeah, the expected value here is 2. So for now, it seems like the formula here for start is I minus L divided by 2, and for end, it is I plus length divided by 2. So let's also consider the other case wherein we have CBBC, right? So CBBC at this value. So we would be applying both these I and I plus 1 considered to be center. So at this value, the length is 0 and at this it is 2, right? So here the value of I would be 1 and the length would be 2, right? That's what we are concerned about. Uh, the first value where the length is 0, that is not very important. So start is equal to I minus length divided by 2 is what we have done earlier, and end is equal to I plus length divided by 2 is what we have done, right? So at this value, the length is 2 and the value that we have here, I is 1. So if you consider these values, it would be 1 minus length, which is 2 by 2, which is 1, which would be equal to 0. But the expected value should actually be 1, right? Because we are starting at index I and we need the end value to be this value, which is so 0, 1, 2, 3. So we want the start value to be 1 and the end value to be 2. This is what we are expecting. So here this would be 1 plus 1, which is 2. So this is as per the expectation, but this is not as per the expectation. So a simple change that we can do is if length is 2 uh, and the current index is 1, we would not want to. So let's consider a better example here. So CBBC, I think I wanted to consider that, but I've considered this here. So in this case, CBBC, starting at this and this. So the indices are 0, 1, 2, and 3. So the length uh, of the longest palindromic substring is 4 here. So L is equal to 4 here and I is equal to 1 here. And the values of start we are expecting. We are expecting it to be 0 and end value we are expecting it to be 3, right? So in this case, I minus L divided by 2, I plus L divided by 2. Let's see if this formula works out. So at I is equal to 1, we would take it I, which is 1, minus 4 divided by 2 is 2, right? So 4 divided by 2, which is 2. This in this case it will be minus, so 1 minus 2, which is minus 1, which is quite dangerous, right? We don't want that to happen, and in this case it is 1 plus 2, which is 3. So the expected value here is matching, but here it's not matching. So one thing we can do here is we can simply subtract uh, 1 from here. So length minus 1. So 4 minus 1 will give us 3. So in this case, what happens is 3 by 2 will be 1.5, which will be considered to be 1. So 1 minus 1 will give us 0. This will be fine. But let's see if the same formula works out here. So in this case, right, we have a length of 3 here. So if we make it 1 minus 3 minus 1 divided by 2, what happens is this will be 2, and 2 by 2 is 1. So 1 minus 1 is equal to 0. So it works out for both the cases. So the formula, the final formula is this one, start and end. That's what we found out. So let's jump into programming, and let's try to solve this considering the values. So for every index, we consider that to be the center, and that and the next value to be the center, and we find the length that we can get. So let's jump into programming and let's try to solve this. So this is the problem. It's longest palindromic substring. So let me try to solve it here. So the first thing that we would need is we will have to loop through this, right? And then we will have to have two lengths here, L1 and L2, right? And we need another method that we will implement. So what that does is it'll take the string, it'll take the center value. So the center value would be I, and uh, it would be I and I plus 1. So to support both of them, I'm just setting it like this, I and I plus 1. So this is for the later case. I and I plus 1 is for this case where we would be checking two values together, like C, B, B, C. First we'll be checking for C and B together being the center, and then B and B together being the center. To check that, we'll be using the second one, and what we can do is together we can have a new length, which would be something like this, math.max of L1 comma L2. Okay, and then once we get the length, we have to identify if it is the best one so far. So that so first of all, we will have to return. So we will have to return the substring. So the solution here is not length 4 or length 3 or whatever. We need the start and end values so that we can make a substring of this. If given the question CBBC, we will have to output CBBC. Uh, and given the question CBBD, we will have to output only B and B. So we will have to identify the start and end indices, and we will have to uh, get a substring of it. So substring from start till end. So we have considered the values of n to be 2 here, but uh, we need it to be 3 so that 2 will be considered. It is not inclusive here. So if we get CBBC, then end value would be 4 here. We want the substring to take 0 and 5, not 4, because 0 and 5 will give uh, CBBC. 0 and 4 will give CBB, right? So that's the reason we would want to make this n plus 1. So the start and end values aren't declared yet. Let me do that. Just initializing it to 0. Okay. So how would we get the length here? How we want to compare the value of length and start and end. So the simplest thing that we can do is length. If the length, the current length that we've identified is greater than a simple formula, which is n plus 1 minus start. That is the exact length we are getting here, right? So the same thing that we are writing here, we are writing over here. If that is the case, then what we do is start is equal to, so we had a formula here. Start is equal to 1 minus L by 2. No, it's not L by 2, it's L minus 1 by 2. That's the formula. This one is the formula. Uh, so I minus length minus 1 divided by 2, right? And end would be I plus length divided by 2. Okay, perfect. Now what we have to do is we just have to implement this method. So it is a private method and it returns the length uh, of the longest palindrome, and it takes a string s, and it takes the left side value and it takes the right side value. So the first thing that we have to do is we will have to return the we have to return a value something like this. Let's modify this value based on uh, the requirement later. Okay, so we will have to write a while loop and it should exit when length is it fails this while loop, right? Whenever it fails this while loop, it will have to exit. So length will have to be greater than or equal to 0. Left side value will have to be greater than or equal to 0, and right side value will have to be less than the string length. And we'll have to make sure that the characters at left is equal to character at right. So this is the check where we are doing the left side value and right side value are equal or not. If it is equal, what we do is we go one step towards the left and one step towards the right. So whenever it is equal, we do this step, and once we do this step and it fails this condition of L, uh, so let's consider the values here. When exactly would this while loop exit, right? So let's jump back to this. So let's consider the values C, B, B, C. So we'll start at this point. We check if B and B are equal. We realize that B and B are equal. What we do is left pointer was pointing at index 1, 0, 1, 2, and 3. And a right pointer would be pointing at index 2, right? Next, what we do is we move the left pointer to index 0 and right pointer to index uh, 3, right? So at this point, we identify that CBBC is a longer palindrome, uh, and these both are equal. The characters at 0 index and 3 index are equal. So what we do is we make L is equal to -1 and R is equal to 4. At this point, the while loop that we have over here, L greater than or equal to 0. This condition itself has failed, and then there is an and to the right. So it will automatically exit the while loop. So it will exit the while loop with values r is equal to 4 and L is equal to -1. And in this case, we want to return the length, and the length that we expect here is actually 4. We expect it to be 4, and we have R value which is uh, 4, and we have L value which is -1. So if we do a subtraction here, so R minus L, that would give us 4 minus of -1, which would be 5. But we are expecting 4. So the simplest thing that we can do is do a -1. Let's check if it works for this one as well. So the values that we are getting over here will be uh, BAPAC. So let's consider this value or this value, anything works. Let's consider this to be the center. So this will be the values, right? So the left value initially starting would be 0, 1, 2, 3, 4. It would start at 2, and right value would also start at 2. So we decrement the left pointer to this one and right pointer to this one. So here left pointer would be 1 and right pointer would be 3. Uh, at this point, we check the characters at this and this are equal. So what we do is we jump one more point to the left. So the left pointer is here and right pointer is here. So left pointer is at index 0 and right pointer is at index 4, which is not at all a problem. But the characters at left pointer and right pointer are not equal. So because of that condition, this while loop will exit. So while loop will exit with values uh, r is equal to 4 and L is equal to 0. But we want the length to be this much, which is 3. So r is equal to 4, L is equal to 0, and the expected length is equal to 3. So in this case, r minus L would give us 4, but we want 3. So -1 would give us 3. So in both the cases, we could see r minus L minus 1 is the right formula here to find the length. So let's write that. R minus L, and then there's another minus 1. That's what we need. Okay. So let's try it out. There's a compilation error. Okay. What again? Okay. How could I write this? I less than accepted. Let me try submitting this. Okay, it's 88%. Memory is also quite good. So that's it for this problem. So what is the time complexity and the space complexity? Let's analyze that. So in this case, what happens? We consider one value to be the center and we move around it. So the maximum that we can get at any point would be n, and we do it at most n times. So uh, it's n square. The complexity would be O of n square. That's the worst case scenario, but yeah, at every point, let's consider we are missing one or two values and we move on to every other value. So in that case, n square is the time complexity, and the space complexity. Space complexity is easier to analyze from here. Are we adding any uh, arrays or lists or anything? Nothing. So the space complexity is O of 1. So that's it for this problem. Thanks for watching.